Hey YouTube, and welcome back. Now, in the last video, we had a fun time. We were able to host a backend service, right? An IoT application backend service. We were all which consisted of multiple APIs, hosted in their own containers, right? And we also were able to host a MongoDB database. Now, I might have forgotten to show it in the last video, but essentially, if you looked here, you would see here that there is a MongoDB image right here, right? So we were also able to host our RabbitMQ server, right? So we have our RabbitMQ server that was hosted, our MongoDB service that was hosted. We also hosted our web API service, our devices service, authentication API service. This service contains everything combined in one single API. It's just there in case you wanted to test something or you wanted everything together. It just shows you how you could do it, right? Fast API is really good at breaking things apart, right? And you hosted them separately, and really good tool when it comes to that. We also have our users API service, our telemetry API service, and our groups API services. So they're different REST API services together with our MongoDB and RabbitMQ services, right? We also were able to host our dashboard, which is our front end. And we talked about that. We looked at this very cool and nice dashboard, right, with options to see telemetry data, change accesses, and also create profiles, right? Here is our dashboard on our Docker, right? We have a dashboard service right there, and then we also were able to create an event hub service. Now, event hub service is always listening to our RabbitMQ service. And we showed that right here where we said, okay, there are 4 consumers. And we showed in the code, right, where we had 4 consumers created. And those 4 consumers are listening in case there is a message. If there is a message, they would pick the message and they would process it correctly. And so we were able to do all these cool stuff, and we were able to show how to host all this cool stuff. Now we need to make everything come together. And to make everything come together, we need to install our Raspberry Pi. Now, I know in our previous videos, we've always talked about how cool the ESP32 is and how nice it is and how much stuff it can do. However, what we're about to do, and you can see from the scale of the application, is pretty intensive, and you can't do it. Really, you probably can, but it would take a lot to do. A lot of work and a lot of memory management on the ESP32, if it can do it, right? So it's just going to take a lot, because you're going to see the Raspberry Pi application and how we set things up so that things can move really smoothly. And we'll talk about first how to install our Raspberry Pi code, which is written in Python. Then we will then talk about what really the code is doing, right? We'll probably install the application, run it, and then talk about what really is happening, right? There's a bunch of stuff happening in it. And you would really, I know you would like this. So stay tuned. I'd really love to see what comments you have, at the end of this. And I really, really hope this interests you in IoT. I know this is many, many steps up from what we have been doing in the past with ESP32, but again, everything comes together to get you a solution. I just thought it would be cool if we could have something that really shows this in this class so that anybody could look at it and, very easy to install. You saw how we just installed this in Docker in very few steps. It didn't take any time at all, and the same thing you're going to see on the Raspberry Pi. Very easy to install. And I hope you really enjoy this. Feel free to like, comment, and share this video. And now let's get into it. Okay. Now, very first thing we want to do when we want to install our Raspberry Pi is Raspberry Pi does have Raspberry Pi OS. It's just an application that you can, for desktop, right? That you can install on your desktop that helps you with installing your Raspberry Pi. Let's just go ahead and go to raspberrypi.com/software. And basically what you'd get is this nice application that you can install on your Mac and or on your Windows, whichever one you're using. It could have been installed on Ubuntu, right? Whichever one you're using, and it helps you set up your Raspberry Pi. You're gonna need an SD card. I hope you have your Raspberry Pi. I have mine right here. So I have 2 different Raspberry Pis that I'm gonna be using. We're gonna do like a small demo, and then we're gonna do a big thing like we always do, right? So again, I hope you really enjoy this, but just take it slowly. Again, everything is explained in the video. If you have any questions, just feel free to message on the, and then I'll see, if I have some time, I will definitely be glad to answer your questions, right? So let's go ahead and install this. I don't have this right now, so let me install the DMG for that on my Mac, and I'm gonna install that. Okay, so here we go. So just gonna get that installation going, and that's it. I'm done installing. All right, so now open up the application. So we're done with it right now. We're done with that, right? So let me open up the application. So now the application is open, right? We could just, select the type of Raspberry Pi that we want to use and get ongoing with it. But we want to be able to set up our Raspberry Pi so that on boot, we would have SSH enabled with a user already in the system, right? To do that, go ahead and press Control-Shift-X. Now, once you press that, if I say yes, maybe under Windows, it won't really ask you this, right? But if I say yes, it will just load up my Wi-Fi details and pre-install it already, right? So I guess we'll just say no for now, right? I'll put it in manually. Now that we have this up, right? So we want to select a host name for our Raspberry Pi. So I'm going to select a host name. Now, the host name helps you to set up your Raspberry Pi so that it can be seen on the network, right? So basically, your Raspberry Pi would be seen as, instead of trying to look for an IP address, right? Instead of always trying to search because the IP address could change anytime the Raspberry Pi comes on. Instead of always looking for that, you can just connect with the host name and not have to worry about IP address. So let's give our Raspberry Pi a host name. I'm going to give mine Raspberry Pi 001, right? 001. That's a lucky number. I want to set a password for it, right? And so username and password, I don't want to use my name. I think for this, the best thing to do is to set it up for the default user. The default user on the Raspberry Pi is Pi, right? So you can set any password if you want, like any password you want, but I just like using Raspberry because that's like also the default password. So I'll type Raspberry. Okay, so now I've set this up. Now, again, you can set any password you want. So I'm gonna go ahead and set up my wireless LAN, right? So that the Raspberry Pi can connect to my Wi-Fi. The wireless LAN country is the United States. Yeah, here we are the US. Oh boy, that was difficult to get to. Okay, now we want to set our time so that our time is always correct. And keyboard is the US. Okay, that sounds good. So we've set up our host name. Username is Pi. Password, I put in my password. SSID, my Wi-Fi SSID, the password. And the country where my Wi-Fi is, time zone and all that. Now I'm gonna go to services and I'm gonna enable SSH. It's gonna use the password authentication. You can use the keys, but I'm just gonna use password for now, right? So everything looks good still, right? Options, nothing else. So I think that's all you need to do and looks good. And now we save. Now that I've done that, if you have your micro SD card, you probably want to plug it into your computer now so that we don't forget. Right, so I'm gonna go ahead and plug this in. Choose a device. I'm using a Raspberry Pi 3. Where is it? Yep. So I'm gonna choose a Raspberry Pi 3. choose an operating system. Now you could choose anything, but I don't want to load the Raspberry Pi with a Raspberry Pi desktop because this is gonna be on an IoT device. Doesn't really, sorry, I don't want to load it with a desktop view, like something that will show like the UI for the desktop. I just need it to just boot into command line, right? You could load the default Raspberry Pi OS, right? But basically just, I prefer to just boot into command line. So I'm gonna select Raspberry Pi OS order, right? And I'm gonna select the fourth one. This one has the desktop environment and I don't want the desktop environment. I just wanted to boot into command line because if you set up the desktop environment, then I need to put a monitor and configure my keyboards and all of that stuff. And I don't want to do that. I just wanted to plug in my Raspberry Pi, let it load, and just let me SSH into it from my desktop and work from there, right? Easy. Now, so I'm gonna install the Raspberry Pi OS Legacy 64-bit for the Lite. So I'm not gonna have a desktop, so it says a port of Debian Bullseye with security updates and no desktop environment. Sounds cool to me. So let me choose a storage. Now I had something in there before for my files for previous project I did on Raspberry, but if you put this, you can format it before you want, before you do this. But even if you don't format it, it will format anytime you do this. So basically just select that and now next. And now it asks, would you like to apply the OS customization settings? Of course, those are the customization settings that we put in initially, right? Our Wi-Fi and all that stuff. So I'm going to go ahead and select yes. And it says all existing data on your mass storage device will be erased. Are you sure you want to continue? Yes, please. So now let me put in my system password. So this is gonna take a while, at least maybe 10 minutes or less, maybe like 5 minutes. So I would pause here, and once it's done, then we will come back and continue from there. Now we are done, right? So it says Raspberry. So after I finish installing, then it verified. So it says Raspberry Pi OS Legacy 64-bit Lite has been been written to your mass storage device. You can now remove the SD card from the reader. Okay, continue. So for this project, I'm gonna be doing two different Raspberry Pis. So for this video, now one will be a simple connection, and the other will kind of have a lot more to it. So what I'm gonna do is I'm gonna install a second Raspberry Pi. Now, please note that you can't have the same Raspberry Pi with the same name, right? So two Raspberry Pis with the same name on the local network, not really recommended, right? So I'm gonna have to reinstall it. Now I have my second SD card plugged in. Now we're gonna install the same thing. So just please bear with me. So I'm gonna have to click the Control-Shift-X again. So the second Pi it's gonna pretty much be the same thing. The only thing is I'm gonna change this to 002, right? So I have a Raspberry Pi -001 and a Raspberry Pi 0-002. So let's save that. We already have the Pi Legacy one selected, 64-bit. That's already been selected. Let's just confirm. Raspberry Pi OS order. Raspberry Pi OS Legacy 64-bit Lite. No desktop environment. Okay. Now, choose a storage. So I'm going to choose a storage. Next. Apply customizations, yes. All existing data will be erased, yes. And we will pause here for a few minutes. So now it's completed. While that was happening, I went ahead and set up my my circuit, right? So my circuit is right there. It's just two LEDs, right? There are two LEDs with two button switches, and it's connected to the Pi. Now, if you need the circuit is available in the code for the Raspberry Pi. So if you go to the repositories, and if you go to the Docker IoT Connect Raspberry Pi, and there's a circuit folder, right? There's the simple circuit, and then there is the more complex one, which is the two videos that I said I was going to do. So in the simple circuit, that's what I have connected there, right? You can see how it's connected, all the wires, just a few wires. It's just two buttons, right? Two buttons, two push buttons, two resistors, and two bulbs, right? So for the resistors, you can use 330 ohms. The two push buttons are right here. We're just going to monitor these two light bulbs, right? And this switches, if you press on them, one of the light bulb can come on. I think this first one's for the red, and this is for the blue. So if you click on it, it will affect the light bulbs. Now for the second one, right? It's a little bit more complex. So basically what we have is the same Raspberry Pi 3. We have the same setup from before, right? Two buttons with two light bulbs, right? But we wanted to add other things. So we have a sensor, DHT11 sensor, but I'll be using, mine is a DHT22. Right, so if you have a DHT11, that's fine. You can modify the code to support DHT11. But what I used in this project is a DHT22. Now, there are two types. They're even for this, there's the ones that come with the 4 pins, right? You see 1, 2, 3, 4. However, there's a resistor that's usually added, right? And then it converts it to 3 pins. And I have the 3 pins of the DHT22, and this is the 3 pin for the DHT11. Whichever one you get, you could just look up how to connect it, and it should be fine. It's usually just the voltage, the signal, and the ground, right? And then there is another 2 buttons and 2 motors, right? Electric motors. And those motors for me have fans, right? I have a red fan and a blue fan, right? These motors are controlled by a PWM driver, right? So you'd probably want to connect them to a PWM driver and then link them up to the motor. So whichever one you buy, this one I got from Amazon. The one I'm using, I got from Amazon. If you wanted to use the same thing, you can get it from Amazon, right? But essentially, if you press this button, the first fan comes on, the blue fan comes on, and I'm sorry, the red fan comes on for this button, and then the blue fan comes on for this button. And the code is written where the button has different levels, right? You can, when you press it the first time, it increments by 25%. So if you press the first time to be 25, press the second time 50, 75, and then 100. And then the next time you press, it will be 0. Right, and then you start all over from there again, right? So that's how the code is set up, right? And this is the circuit that we will be using our code for, right? So again, the circuit diagram is located in the Raspberry Pi code. Once you have that, you can download that. Setup instructions are very easy. They're all down here. So let's go ahead and install. So this has been fully copied into the mass storage device. So I just click continue. Let me go ahead and plug in the first SD card into my Raspberry Pi. So the first time you put this on, it's gonna do some installation. I don't have a spare monitor to use right now. That's one of the reasons I didn't want to do the desktop version. Well, at least one of the reasons, I guess. No, well, not the main reason, but at least one of it. So it takes like 4 minutes to initially boot, and because it's booting the first time, right? So I'm just gonna set my timer and wait 4 minutes, and then we'll be back. Okay, so it's over 4 minutes already, and it looks like my Raspberry Pi has a steady green color now. So I think it should be fine. I think we should be fully installed. So now let's go ahead and just connect to the Raspberry Pi. So I'm gonna go ahead and open Visual Studio again. So let me just open a new window in Visual Studio. Visual Studio is a great tool. Let's connect to the Raspberry Pi. So I'm gonna, again, just a reminder, we need the remote SSH. So if you haven't installed remote SSH, right, just go to your extensions right here. Either you install remote SSH directly, but I prefer just installing remote development. It installs a whole bunch of tools, including remote SSH. That's really cool and really nice for this kind of work. All right, so let's get back into it. So just click on the icon down here like we've done previously, right? So just move this up in case you're not seeing that. So click on this lower blue icon here, and now let's connect current window to host and configure host. So because we haven't configured the host yet, right? So let's type in our host information, right? Raspberry Pi -001 dot local. Raspberry Pi -001 dot local. Okay, now let's connect again. So if we were to connect now, let's try to connect again. Click on this icon, connect current window to host, and then Raspberry Pi simple. So this is the first time we're connecting, so it has the fingerprint. So are you sure you want to connect? Yes. So continue. That's the wrong user. So close remote. Let's go back again. Connect to host, configure SSH, configure. Sorry about that. I had the root one from the previous one. That's why copy and paste sometimes really isn't good. Right? So we have Raspberry Pi simple. The host name is Raspberry Pi -001.local, and then the user is Pi, right? Remember that. Okay, now let's go back again. And I know some of you caught that already. So let's go back again and we'll connect current window to host. We'll do Raspberry Pi simple. And now let's put in the password. See if that works. Does it work? I like opening the terminal to see if it works. Oh yeah, it's working. So it's setting up the SSH host, and then it's going to be installing VS Code on the server, right? So it's started installing Visual Studio Code in the Raspberry Pi, right? So because this Visual Studio Code that I'm using here will be talking to the other Visual Studio Code server on the other computer, on the Raspberry Pi rather. So now it's asking for password again. So I type in Raspberry. And now we are connected. Yay! Isn't that cool? Look at that. Well, this is Pi Raspberry 001. We're inside the Raspberry Pi. We can actually start writing code. So now that we are inside the Raspberry Pi, let's make a folder like we did in the other one. We'll just make a folder for our applications. So mkdir, we'll make a directory called applications, APPLIs. Okay, now let's check. Applications folder is there. So now I just prefer connecting to that folder directly. So I'm gonna open the folder, right? And I'm just gonna go to the applications folder, right? And I'm just gonna do okay. And it's gonna ask me for my password again. And I'm gonna trust this computer. Yes, I trust the authors. And now put in the password a second time. And I think we're there, right? Yeah, we are actually there. So let's just go ahead and download the application. I think to download the application, just make sure you are here on Let's Code with Francis, right? And if you just type in bitbucket.org/Let's Code with Francis. I'll put the link in the video description of the video so you can easily access it. But you can access the Docker IoT Connector Raspberry Pi, and then just go to downloads. We can just download this repository. Or you can also go to branches, and we have it in the master branch. So just do download zip. And there we go. We've downloaded the zip file. We can just unzip it, right? So let's double click to unzip. And now that we've opened it up, we can just copy it and drop it into our Raspberry Pi. So let's do that. And there we go. Are you sure you want to copy this folder to Raspberry Pi? Maybe we should have named it first, huh? That's a very long name. So that copy folder. And now that folder is in there. So now the next thing we want to do, we want to cd into this folder. Cd into simple. There is a script here that we need to run, this install.ssh. Now this installs everything that we need. If you look at the script, it first gets the update. It then gets the build essentials update for Python 3, right? Then it installs SQLite. We're using SQL as a database, and you would see that later. And then it also, it just prints out the SQLite version here, right? If you run the code and your database is here and you run the script again, it will delete your database unless you take out this line. You could take it out if you want. And then it installs the requirements.txt. Those are the things that we need from pip, right? So pip3 install requirements.txt. If you go to requirements.txt, we're just using Pika to connect to our AMQP, right? That's our RabbitMQ. We're using Pydantic just to make nice classes that we can use. We're using python.env to get our environment variables because we have some environment variables over here, right? And then we installing this Adafruit DHT 1.3.4. Now that is to connect to the Adafruit, the DHT sensor. Now, for the simple one, we're not using that sensor like we talked about earlier, right? But for the other one, the other circuit, you would see that we would need that. So, it's just going to install all of that. If you're doing the simple one, fine, you could take this out. But it's been imported in the code. So I think it's just nice if you just leave it there because there's a lot of imports in the code that require that. And you might have to spend your time taking that out. So these are the 4 things that are really needed to get this going, right? So basically you need to run these commands. It's actually here in the source code. You'd see it here. We have to make this a script. We have to make sure that it's an executable script, and then we have to install it, right? So I'm just gonna copy it from here since it's easier for me, right? So I'm gonna copy that, paste that. So this will make that into a script that we can run on this Pi, and then sudo install this script. And now when we paste and run the install.sh, it now installs everything we need. So it might take a while, just wait for it. Okay, there we go. So it installed everything. So the last line here says it can't find the file, so it can't remove it. Okay, that's fine. All right, so now our application is actually fully installed. Like, that's all, really. We're ready to go. If you look at this file, there are 2 main files. There is a main.py, which is the actual code you need to run, and then there's a main.sim. Now, the sim is more like a simulator, and this is like if you don't have a Raspberry Pi and you want to run it on maybe your computer, you can use the main.sim to do that. It's just a simulator. However, because this main.py, you would have to take out a few things. You would still need to install the requirements, but you probably have to not install the Adafruit DHT. So if you want to run the sim, you probably don't need this because it's not meant for a computer, right? This is a Raspberry Pi code, right? But everything else you can install on your computer. So just make sure if you're going to run the simulator, it's almost the same code. There are some differences, but just make sure if you're going to run the simulator, just take that out, right? And also if you're going to run the simulator, you might want to delete the main.py. Just, the simulator is there for you. You can use it however you want. It's a really good simulator, right? Let's open main.py, right? And let's take a look at the code first. So here we see we're starting database connection and device provisioning. So the very first thing we need to do first is we get a connection to our database, right? We create the required tables for our database, right? When we get the connector, we get the DB table helper class, right? And then we use it to create the tables for our database because we need certain tables, right? If for some reason your device has been provisioned previously and you need to reset it, you might want to use this method, reset registration data, because this would only let you kind of register once with this code. And after that, anytime you boot up your Raspberry Pi, it will already have the configuration information and it will just use it. But it has already set up everything on the cloud for you, right? So now we will then check if the device is registered. If the device is not registered, it's Pi registered. And if the Pi isn't registered, then it will set up the registration information. Now it's saying, should we use motors or should we use sensors, right? For this particular exercise, for this particular example, we are not gonna use the, let me expand this a little bit, make it bigger. For this particular example, we don't have any motors and we don't have any sensors, right? It's just an LED. So what we're gonna do is we're just gonna make sure we set use motors to false. And then we will do use sensors to false. Now that makes sure that we don't go register things that we do not have. And if you put that to true, your code might also crash because it might be looking for the DHT sensor and the sensor is not available. So then your code would crash, right? So just make sure you set this to false. Really nice and easy, right? Now the ID for what this ensures is that we're setting up two LEDs, our red LED, which is that, and our blue LED, right? So, and these are the IDs for those LEDs that will be registered in our platform, right? So now let's go back. So here now we register the devices to the cloud. These are our routes, right? So our telemetry exchange name, our command exchange name for commands. So when you send a command to the device to do something, right? That's the exchange name for that. Our queue name, right, for telemetry, and our route name for telemetry. So these are just configuration stuff for AMQP, RabbitMQ. Now let's run our code. So all we have to do is say Python main underscore pi dot pi. It's fun, pi dot pi. Okay, now before you run this, you have to create a group that these devices will be logged onto. If you run this without creating a group and putting in the ID for that group, it's not gonna run. It's gonna tell you that there is no group to put your devices. In order for you to connect, we need to have the IP, right? So basically, that was why I put this here. So we don't just, you can't just connect to anything, right? So you need to go and get the IP. So all you have to do is to fill in your host IP. So we could just put that in here. So we don't need a HTTP. All we just need is the host IP address. Copy. Host port is 7000. Host URL. Now we run. So Python main.py. We try to connect. Detail group does not exist. So you see what I've been trying to explain. So basically, you need to create a group, right? Because we don't know. So basically what just happened here is that this device tried to connect to our provisioning service to provision the devices that are registered to it, right? And when it tried to do that, the provisioning service said the group that you have here, which is this default group that I put here, right? It doesn't exist in our database, right? So I can't register you to this device. So please, I probably should have made mention here that please update this. So maybe in the one that goes up, after this video, I will do a similar thing like I did here to just tell you to please update your group ID. So let's go ahead and create a new group, because this group we already put some sample devices in it, and we don't want to mess things up. So now let's create a new group. So I'm just gonna create a group for my home in Atlanta. So Atlanta home. And parent group is none. I don't want to link it to any other group. I want it to be on its own. Location is in Atlanta. And type, we don't really need that. Address, I don't want to save that right now. So those are not really, if you want to put it, you can put it. And now I click on create. Success, Atlanta home has been added to the system. Now you can see we have a new group called Atlanta home. And now what we're going to do is we're going to copy this group ID, right? Okay, sometimes it doesn't. You can probably get it from the URL anyways. I think it should be here, right? So we copy this group ID, and now we would paste that in here with the group ID field. So it looks like our group is created. Now let's run the code. Here we go. Oh yes, our devices have now been registered. Provisioning data was saved, and now data is being published. Can you believe this? We have essentially provisioned our device, right? So if you come back here to what we have always talked about with our platform, right? Okay, let's do this. So basically what had just happened is our Raspberry Pi connected to our provisioning service and provisioned all our devices, which is 2 devices. Not much, but it's enough, right? So basically, and our Raspberry Pi is now publishing data. And all that data now is going into our database. Now this database, we can check what is happening in our database. I think there is a extension called SQLite Viewer. You might want to install that. Let me see if I can find it. It's a great tool. It doesn't give you ability to change things, but at least sometimes I want to change things, but it only gives you the ability to view things, right? But it's a great tool. So let's install that so that we can see what's even going on in this DB, right? So I think it's installed now. Now let's open our DB up. So we open the DB, open anyway. We'll use SQLite Viewer, and you can see what just happened in here. Now, these are constants. Remember when we connected, right? Our connection string came in, which includes information of what we need, what our application needs to connect, right? And then when we got our connection string, these are the devices that were registered. So 3 devices were registered. It registered the gateway, right? And it registered the red LED and the blue LED, right? And then it also registered we also have the states for our devices, which is the current value, right? So these are the current values for the state. So these will probably update as time goes on and it's checking our devices. This will change, right? And then we have sensor settings, which we're not really using. This is when you set a setting from the cloud for a sensor when it comes on and all of that, right? So that's just basically, now let me stop this application. You see what happens. So I just press Control-C, and you can see here, right? We tried exiting gracefully. So it looks like our code is working, right? So Control-C pressed, exiting gracefully, and it broke through and cleaned up our code, cleaned up everything, and now we're back out. Now, the reason why I did that is we want to minimize this, and I want to show you something. All right, so let's go back here. So basically, let's start the application again, and now I'm gonna run it again. So just watch. You see the LEDs, they're on, the blue and the red, right? They're on for 3 seconds and then they go back off. Just wanted to show you that. Now, the next thing I wanted to show you is to make sure our provisioning service is working. All right, so let's go back to our application quickly. Well, basically all our devices have been registered. So those 3 devices, the Raspberry Pi, the red LED and the blue LED, they have all been registered. and you can see the device information. This is the device name, the location. It doesn't have a parent device. Its profile is default, and it's a gateway. Now for the red LED, it does have a parent device, which is the Raspberry Pi, which is the Raspberry Pi Simple that we're using right now, Raspberry Pi 891, right? And it does have its profile LED, right? So now let's go into telemetry. Okay. So here we are in telemetry, right? The default is to sensor, right? There's probably data coming in already. Let's go to state. So you can see here that we've been getting data from those two devices, the red and the blue. If we cut out the red, you can see the blue, right? That's the orange line. And if we cut out the blue, you can see the black. So we're getting some states. The Raspberry Pi is always on, right? So it's just saying on, right? Now that's the black, right? Now the red LED is fluctuating up and down, right? And then the blue LED, when we cancel the red LED, you can see that it's also fluctuating when it went on and when it went off. That's probably around that 3 seconds time that we used, right? Now let's reload this again. Just make sure we have the latest data. Let's see if new data is coming in. And now you can see all the data coming in and at what time. All right. So now all this data is coming in. You can see as the data is coming in, on, off, right? Telling us when it's on, when it's off. We can also see the brightness, right? So for brightness, and that's why we talked about the profile. The profile helps us able to map this without really doing much work, right? But you can see that it's right now at 75%. There was a time when it went to 50%, but it's maintained. I guess they initially boots up with 50%, and then we set it to 75. So that's probably when we boot it up. Then it goes to 75, and then it stays there, right? Now we have this data. Now let's see if we can connect, right? So we try to connect. Now you can see data is coming in, right? So the red LED right now is off, right? The blue LED is off, but their brightness is 75. So if they were to come on, their brightness will be 75. Now I'm gonna move this out of here so we can see and do this. So you can also see down here that data is coming in, but the data just says that it's off. Okay, the brightness is 75, right? And then if we go to the state, you can see here, this is the gateway is on, but the Raspberry Pi is off, right? So it's at 0, right? And same thing also, if we were to clean the Raspberry Pi, we would see that the other one too is off. Okay, so what do we want to do? Let's go ahead and put on our light and see what happens. Right, so we have blue LED off, red LED off, right? So now I'm going to put on the red LED and we'll see what happens. Okay, so we can see here that we put on our red LED using the switch and the red LED came on. Our blue LED is still off, right? And so if we try to put that on also, now our blue LED is on, right? So basically we can see what just happened here. And now we can see our state here has also changed. They've moved from the off position and they've moved to the on position with the red LED coming first and then followed by the blue LED. So again, if we were to turn off the blue LED, takes about 10 seconds to get an update. Here we go. So now the blue LED has come back to off, right? The red is still on, right? The blue LED has come back to off. The red is still on. And now if we turn that off also, Now our red LED is off, right? So you can see how easy this is and how simple this is to install. Now, I know there were some things I need to clean up. I will do that before I push up the code. I hope you've enjoyed this so far. However, before we go, I wanted to show one last thing. So here's our device, all right? Now, let's send a command for our LED to our devices to come on. So let's turn the red LED on. We pick the red LED device, and we set the state, and we say on, and now we send the command. Now you can see immediately what happens here. Like let's explain that. What happened here was that when we sent the command was sent to the RabbitMQ server, right, from our dashboard. So if we come back here, the command was sent from our user here, and it was routed to our telemetry management service. Our telemetry management service then sent that command to the RabbitMQ server right here. Microcontroller, the Raspberry Pi, is subscribed on a particular topic. It receives that data on that topic, and then it's able to route the data to the correct device connected to it. Now, if you look at the code, you will see the installation for the topic, right? So if you went to Threads Manager, you would see that there is a topic here. It starts with the group ID, the Raspberry Pi ID, and then there's some other information. This just means that anything else, but basically anything after this Raspberry Pi can receive. As long as it starts with this group ID and the second data is this Raspberry Pi ID, anything after that, then it ends with command, which is this last here. Anything in between that, so if I might have 20, 30, 50 devices, as long as they start with the group ID that's there and the Raspberry Pi ID and end with command, I should receive that. And once I receive that, I will then route that to the proper device. And that's what's happening here. Now you can read a lot more about that, read about topics and RabbitMQ and see how that works. If you were to go into the RabbitMQ, you would see that we're seeing data coming in and it's being routed. The consumers are taking it, right? We have 6 consumers in total there. And then if you went to the queues, right, you would see that there is this topic here, right? So this is a topic, right? And that's where our data is being routed from, right? So again, this is fairly easy. There's a lot in here, a lot of technologies that are being used. Just take your time on try to understand it. Feel free to ask any questions, right? So you can see here that the Pi device there, is set, right? I can change the brightness also. Let's say I wanted to reduce it to 25%. Just watch the LED. I send that. Now you can see the brightness is reduced to 25%. And let's say I want to bring the brightness up to 100%, right? I can send that. And my brightness is now 100%. Same with the blue LED. You can maybe turn it back on, right? You can turn it back on and say, come on, blue LED is now on. I could change the brightness and say, all right, I want you to be at 10%. And now let's send that. Now it's at 10%. And I say, okay, now I want you to be at 50%. And now I can send that. It goes up 50%. And now I can say, I want you at 100%. Right, and I can send that, and now it's at 100%. And if we were to, let's say, there's multiple time ranges here, right? We have multiple time ranges here. And let's say we wanted to get data for maybe 30 minutes, right? We can load the data for 30 minutes, what happened in the last 30 minutes, and then we can load the brightness. And you can see how that is happening, right? So you can see all the state changes, the brightness changes when it was at 50 and went back to 70. And when we set it back to 100, and you can see what happened if we cancel the red, you could see the blue when we set it to 50 here, and then when we brought back to 100. And this is probably when we set it to 10. All right, so everything is being drawn out. The charts are there. It's just a simple application, I would say. All right, so Again, I hope you really enjoyed this. I will try to do another video for the complex one because I feel this is already too long and I'm getting tired anyways. So again, feel free to like, share this video, and I will see you in the next one. Thank you.